Good morning, students. This is the session 1 from the chapter of oscillations, and this is an introductory session in which I will be giving you a brief description about the oscillatory motion. So here I have written 6 bullet points, and we will discuss each bullet point in brief so that we can have a clear understanding about the oscillatory motion. So in the first point I have written that we come across different kinds of motion in our day-to-day life, and these motions are repetitive and non-repetitive in nature. So let us discuss these two type of motions with the help of example. The non-repetitive motions can be a linear motion, it can be a projectile motion. So these are the two examples of the non-repetitive motion. In the case of a projectile motion, when we throw a ball at a certain angle with the horizontal, with the ground, then the ball covers a certain distance in the air and it falls down on the ground and the motion completes. So the motion in that case, in this case, is not repeating, and therefore it is called a non-repetitive motion. Now in the case of a car which is moving on a highway, let's say and so it is a if the car is moving in a straight path, then we can term it as a linear motion. But in this case also the motion is not repeating because the car is moving from one place to another. So these are the two examples of non-repetitive motions. Now let us discuss about this repetitive motion. So a very common example of a repetitive motion is the motion in a circular path. In the case of a circular path, like this, a person who starts from, let us say this is the starting point. So a person who starts from this point, he will reach back this starting point after a fixed interval of time. So in the case of a repetitive motion, or you can say that a repetitive motion is a motion in which the motion is repeated after a fixed interval of time. So circular motion is an example of a repetitive motion. Now repetitive motions are also called periodic motions. So a circular motion can be termed as a periodic motion also. Now periodic motion is, as I have written on, in this third point, that periodic motion is a motion in which an object moves to and fro about a mean position. So the example of a periodic motion is also an oscillatory motion. Oscillatory motion is also a periodic motion. Here I'm giving you with the help of this example. Let us say this is the pendulum wall clock which we normally see in our homes and offices. This is the bob of this pendulum, and this pendulum keeps on moving. This bob keeps on moving to a certain height on both the ends about this mean position. Now this is the mean position. The mean position means the position at which the bob will remain stationary when there is no restoring force acting on it. So now in this case, the bob of this pendulum wall clock, it keeps on moving to and fro about this mean position, and it reaches to a certain height on one end, and then it reaches to a certain height on the other end. So this is called an oscillatory motion, and oscillatory motion is also a periodic motion because here an object is moving to and fro about a mean position, and the motion is getting repeated after a fixed interval of time. So therefore oscillatory motion is a periodic motion, or you can also call it as a repetitive motion. It is also a repetitive motion because the motion is getting repeated after a fixed interval of time. Now in the fourth point, I have written that every oscillatory motion is a periodic motion, but every periodic motion is not an oscillatory motion. That is, this oscillatory motion, that is the oscillatory motion of pendulum ball clock, This is a periodic motion because the motion is repeating itself after a fixed interval of time, whereas uh, this circular motion is not an oscillatory motion. Circular motion is a periodic motion, but it is not an oscillatory motion, because here you can see that a person is starting from this point, that is S, he will reach this point again after a fixed interval of time, but here the motion is not happening about any mean position. So therefore circular motion is a periodic motion, but it is not an oscillatory motion. So every oscillatory motion will be a periodic motion, whereas it is not necessary that every periodic motion will be an oscillatory motion. Next point is there is one more motion which is called the vibratory motion. So there is a very slight difference between this oscillatory motion and the vibratory motion. I will try to explain this with the help of an example. Let us take the case of a musical instrument, say guitar. So in the guitar, the vibrations which are coming out from the string of that this musical instrument are high in comparison to the this frequency of oscillation of this pendulum wall clock. The frequency of vibration of the frequency of vibrations from the string of a musical instrument, say guitar, is high in comparison to the frequency of oscillation of this pendulum wall clock. Now this pendulum wall clock is performing an oscillatory motion, and this musical instrument is giving you a vibrate. The strings of a musical instrument is giving us a vibratory motion. In the case of vibratory motion, the frequency of vibration is high in comparison to the frequency of oscillation in the case of an oscillatory motion. So this is the only basic difference. However, both these two motions are periodic in nature. Now there's one more point here written, that is the last point, that is the force on the oscillating body is if the force on the oscillating body is directly proportional to the displacement from its mean position, then we call it as a simple harmonic motion. That is, if this is a pendulum wall clock. Now here, when this bob moves to and fro about its mean position, that is when it goes in this direction, and when it goes in this direction and reaches this maximum height. So in this case, what happens? A restoring force acts in the opposite direction of this displacement, and if this restoring force F is directly proportional to the displacement, then we say that this oscillatory motion is a simple harmonic motion, and this restoring force F is directly proportional to minus x. You will find it as you will find this relation as F is directly proportional to minus x in the books. Here minus sign indicates that the direction of this restoring force is opposite to the direction of the displacement. So when the force on the oscillating body is directly proportional to the displacement from its mean position, then it is called a simple harmonic motion. And in this case, this restoring force is directly proportional to minus x, where minus sign indicates that the direction of this restoring force is opposite to the direction of the displacement. So this was a short session on the oscillatory motion. In the next session, I will be discussing about the fundamental concepts of the oscillatory motion. So till then, have a nice day. Bye.